Hi, I'm Drew Purvis. I'm a researcher at Microsoft Research Cambridge, where I'm in the Computational Ecology and Environmental Science group. The mission of that group is to carry out computational science that should let humanity manage our natural resources better. As part of that research mission, we develop new software tools, predictive models in geographical information services that should allow people to carry out that kind of cutting-edge research more widely. Today I'd like to show you FetchClimate, which is an easy, fast way for anyone to extract complex information about the climate, either just with a few lines of code in a program or even just through a browser. So here's our browser running FetchClimate. I'm in Redmond at Microsoft headquarters. So I'm going to zoom in on the area around Redmond, and I can just really easily draw a square here to populate a grid and hit fetch. And what's happening is this is a Silverlight application which is communicating with an Azure service. That service is looking over a large number of large data sets, and it's choosing the best data to answer the query. It's then doing a whole bunch of complex mathematical calculations and sending the result back to our application running in the browser. The answer of that query is now being visualized on top of Bing Maps via dynamic data display, which is another prototype tool that comes from our group. You can see that interactivity. If we hover the mouse over here, and we can see, for instance, that the average temperature in this place is about 2.8 degrees. We can download data. So we just hit download, we get a choice of formats, and we can see all the information that we would need from that query. It's got different times as well, so we can do a query for a fraction of the year or even a fraction of the day. And then we have the air temperature data itself. We have the provenance, so the data source that was used to supply this information, and we even have an estimate of uncertainty. That uncertainty is something that the experts find really hard to assign to data. That was a research project in its own right, and yet that's always supplied every time with a FetchClimate query. Now we can, for the browser version, we can run multiple copies of FetchClimate at once. And so I'm going to show you a couple of examples of fetches that I did earlier. So here's one of wind speed over the eastern US. And that's the kind of thing that you might want to look at if you're an energy company or the government planning wind farms. And in this fetch, I put a string of locations across Africa. And for each of those locations, I've extracted 60 years worth of rainfall data. And we can just hover over one of those points and see what's happening to rainfall. And unfortunately, this looks pretty worrying because it looks like there's been a steady decline in rainfall over the past 60 years. It's the kind of thing we've probably all seen in the headlines recently, African droughts and so on. So thanks to FetchClimate, anyone can get that kind of information really easily. It's live, it's ready, go and find it, have a go, and please tell us what you think.